Hi everyone. Good afternoon, guys. Right, very good afternoon, all of you. Right, so we'll be continuing our quick revision series on highway engineering. Right, until that subject is completely over from all topics, right, we'll be doing this series, you can say, right. And once it is over, we'll be resuming those classes also, right. That tests we are doing, so that live test we have stopped in between, we have paused it in between, right. Those live tests also will be resuming them, you can say, okay, right. So all of you, welcome to Unacademy. Let's crack it, right. Everyone get ready to crack. So these are all 𝐂𝐤𝐴 2024 toppers from Unacademy, those who secured AAR1. And at present, up to this July 7th, you will be having this offer, right. Wonderful offer. So what is that offer? You can say the 𝐂𝐤𝐴 2025 subscription, right. That is 9 months subscription. You will be getting at which one? This is 9,999 rupees only. So 9 months subscription, 9,999, right. So don't miss this, all of you, okay. So 9,999, don't miss this, everyone. So use this code, use the referral code RP Civil and subscribe to this plus and iconic courses, and you will be getting all the benefits, you can see. Now this is the price of your plus subscription, and this is the price of your which one? This iconic subscription, you can see. Now Pratigna batch. So whenever you are going for this preparation for this ES environmental science, this Pratigna batch is started on 30th June with open channel flow by KP sir. Now, so this GATE Pratigna batch is started for which one? You can say on 30th June for GATE civil engineering students, and it started irrigation engineering, open channel flow, and this RCC you'll be having, you can see pictures of it. So new batch for this 2026 aspirants has also started on 30th June only with the same subjects: irrigation, open channel flow, and RCC, you can say. So those who are taking iconic subscription will be getting these books, these printed books delivered to your home within 15 days of your subscription, you can say. Okay. Now, so here, this is my profile. You can follow me at which, and what is the referral code you have to use? RPCL is the referral code you have to use, right? And which class we have discussed in yesterday's class? If you just observe it, what is that we have discussed? Up to which point we have done? You can say, if you just remember. So we have done up to this point, nice, no? So what is that? So this rigid pavement completed, and traffic engineering we have started. In this traffic engineering also, right? Yes, leave the moment 289. Yes, correct, right? So 284 points, speed definitions, and 285, 286 different types of this speeds, right? Space mean speed you are having, is not? These things are done. Relation between this time mean speed and this space mean speed is done, right? Is not clear now, everyone? Coefficient of variation, no. 289 point gets over, right? Now we'll be going for which one? This 290 point, and what is it? You can say traffic engineering, traffic fundamental models, you can say. Fundamental models, right? Fundamental models are this fundamental flow models. We are going to discuss about them, right? 290 point onwards, okay, right. So any doubts in the yesterday's class? Up to yesterday's class, any doubts anywhere? So this highway engineering quick revision, that highway fundamental ones, you can see. This is your first slide, you can say. I can call you Pavan. Okay, very good. Because actually, generally whatever the name I'll see there, with that name only I'm more comfortable in calling actually. That's why. One sec, just a minute. I think here something is there. These yeah, sorry, in this video it will come, not in the display capture. Okay, one second. Is it okay now? Is it okay now? That for me in the background these are visible? Not visible now, no? Yeah, now my image will be clear. Yes. Okay, right, very good. You also attended? Okay. No, you did not comment anything? Okay, so 290, na? Yes, no, 289 gets over. So therefore it will be which one? This is 290th point. Right. So here, what is that you are having if you just observe? What is that you are having? You can say modal speed. So what is that a modal speed if you just consider? Tell me. What is the meaning of this modal speed? You said thank you at the last. Okay, very good. So what is that model speed you are having? That model speed is nothing but it is the most repeated, is na? Arey, what happens here? It is the most. Arey, kya hua? What happens here? Arey, why it is going here like this? I'll write just one line below. Most repeated speed, right? That is your most repeated speed is your model speed, you can say, if you just right. So whenever you are having this you can say, right, frequency distribution karana, isn't? So this is speed will be taken as your model speed, isn't? So this is your speed on this x-axis, that speed in this kmph, and what is that you can say there on the y-axis, that is your frequency, right? So this is your most percentage repeated value, na? So which is speed? This is speed, right? This will be taken as your v model, you can say, yes, na? That is your most repeated speed. Now suppose if no repetition is there, what is the meaning of this? If no repetition of speeds, if no repetition of this speeds is there, and which one will be taken as a model speed, you can say? Any habit, any idea? That a model speed will be taken equal to, what is it? That is your median speed, is not? So what is that median speed, you can say? That a median speed is nothing but which one? So median speed is nothing but your central, no, it is not average value, it is a central speed, you can say, right? What is the median speed? It is the central speed, you can say, right? So central speed means, suppose if you are having some 5 values, arrange all the values in the ascending order or in the descending order, the middle value will be representing the model median speed, okay? And if you have 2 values at the middle, average of those 2 values you have to calculate, okay? Got it? The central value median speed is nothing but, is not? Now what is another one if you just observe? So here 98th percentile speed, right? So what is that 98th percentile speed we are going for, right? That 98th percentile speed will be the speed used for which one? This is geometric design speed, na? It is useful for which purpose, you can say? That is for this geometric design purpose, if you just observe, right? Now whenever you are designing for this 98th percentile speed, so can we keep the speed limit as this 98th percentile speed only, or it is better we keep the speed limit as lesser? If you are designing for 100, you keep the speed limit as which one? This 80, so that what will happen? They will travel with 90 and they will not be crossing 100, yes, na? Based on the psychological behavior of these persons, right, you can say that when you are designing for this 98th percentile speed, na? So what is that we need to do? Tell me. 98th percentile speed when you are designing, right? You have to allow this speed, safe speed, or this maximum speed you have to allow lesser than that only, definitely, right? Isn't it? Lesser than that only you have to allow, definitely, right? So it is your safe speed limit, or you can also call it as which one? This maximum speed limit on the road. Now the speed limit boards you are finding on the road, right? Those are 85th percentile speeds, right? It is not 8, it is 85th percentile speeds, right? Now what is the 15th percentile speed if you just observe? That 15th percentile speed will be taken as your which one? This, it is taken as the minimum, right? Yes, yes, absolutely. So minimum speed limit. it is your which one, this minimum speed limit we have to go for, right? Like that. Is that clear? That is regarding which one, this is speed, if you just observe, right? Is now? Now so next one, right, what is the traffic density, you can say. So do you remember this curve? This y-axis is your cumulative percentage vehicles, and this x-axis, that is your speed in that kmph, we have to take it, right? What is the shape of this curve you are getting? This S shape you will be getting, na? Yes or no? That S shape you will be getting or not, if you just remember. Now next one, traffic density or this traffic concentration, right? Traffic density or which one, concentration, you can say. So what is the symbol we are using for this traffic density or this concentration? That K is the symbol we are using, right? So how can you get this K, if you just observe? That is your 1000 divided by which one, this S, or you can also write it as which one, this 1 divided by this S, right? 1000 by this S or 1 divided by this S, right? First of all, what is that K value is representing? Tell me. That K value is nothing but your, it is a number of vehicles present per unit length, na? What is that unit length? Tell me, at a particular time of observation. So what is that unit length we have to consider? At 1 kilometer we have to take it as a unit length. That number of vehicles per kilometer you have to consider, right? So this is your which one, this S is in meters, and here what is that S, you can say that is in kilometers we have to substitute, na? If you are substituting this S in kilometers, right, 1 by S. If you are substituting S in meters, 1000 by S, right? Because why that 1000? Tell me. That 1000 is useful for conversion from this meter to this kmph, meter to this kilometer or not? Is not? That is what you can calculate, right? What is that S value, you can say here? That S value will be your average center to center spacing between vehicles. Average center to center spacing between the vehicles, right? Or you can also get it as which one, this average length by vehicle, right? Average length occupied by this vehicles, you can say, right? Individual vehicles, right? Got it? Now this one, tell me. Or this and tell me, then we'll move to the next part. Okay, done. That is your 292, and now we'll be going for this 293 point, right? What is that, you can say, if we just observe that a traffic volume. So what is it we are giving? That a traffic volume or this flow, right? How can you get this traffic volume or this flow, if you just observe? That is your number of vehicles per this hour, na? Is a number of vehicles per this hour, or you can also say it as which one, this is a number of vehicles per this day or not. So this is a number of vehicles crossing a given section of road, right? So this is a section of road, right? To cross this given section of this road in unit time, right? What is the unit time you are having? That vehicles per hour or this vehicles per day. Okay, next 294, if you just observe. So now we are entering into this fundamental relation, right, as per this heading. Now tell me, what is that fundamental relation, if you just observe? What is the fundamental relation you are having? First of all, to define the fundamental models, first we should know what is that fundamental relation, na? So what is that fundamental relation, if you just observe? That is your Q equal to that K into V, isn't it? That Q equal to which one? This K into V, right? What is that Q, you can say, if you just observe? That is your vehicles per hour. And what is that K, you can say? That is your number of vehicles per this kilometer into what is that V you are having? That is your kilometers per hour, na? If we just observe it, what happens, right? This kilometer get cancelled, vehicles per hour only you will be getting, na? Units wise it is matching or it is not matching, you can say. Units wise it is matching definitely, na? Yes or no? No. 295 we just observe, right? What is the point? Suppose if that QE is a constant. So whenever that QE is a constant, right, what is the relation between this K and V? When QE is a constant, right, what is the relation between this K and V? Tell me. Speed is inversely proportional to which one? This K, right? Q is inversely proportional to V is inversely proportional to this K, right? 296, right? What is it you can say? Suppose if that V is a constant, right? Whenever that V is a constant, right, what happens? You can say when V is a constant, you can say that Q is directly proportional to this K, right? Now next, what is it you can say? Suppose if K is a constant, right? Whenever that K is a constant, right, what is it you can say? V is directly proportional to that Q, na? V is directly proportional to that Q. Okay, we'll write all these points under this same point only, that is better. We'll make all these in the same point only, that is better. Here, pen is not working. Okay, let it be. Now it is not changing it. Okay, let it be. Right, done. These points are done. Now if we just observe, right, so which one is important for us? Tell me that the maximum flow is only important for us. Where it has gone? It has gone something. One sec. Whatever I have written, it has gone completely. Arre Baba. Is it gone? 1 second. It is there. After this, nothing is there. 1 second. It was not there. It is erased. Okay. Right. So K you are having 292. So what is that? That is your traffic volume or this traffic flow, na? Okay. Traffic volume or this traffic flow. So what is that? Traffic volume or this traffic flow, right? We will be giving the symbol Q. That is your again this is started. I don't know why. It is the number of vehicles per hour, or you can also say it as which one? This is the number of vehicles per which one? This is a day, na? So this is the number of vehicles crossing a given section of highway. This is your section XS. This is section. How many vehicles are crossing in 1 day or in 1 hour? You can say. No. What is that fundamental relation or this fundamental models? That fundamental relation, if you just observe. So that fundamental relation will be which one? This Q equal to that K into V, na? Q equal to that K into V. How do we know that? So what is that Q you can say? That is in terms of this vehicles per hour. And what is that K you can say? That is in number of vehicles per which one? This kilometer, na? Number of vehicles per this kilometer. And what is that V you can say? That is your kilometers per hour, right? When you multiply these two, kilometer cancel, vehicles per hour will be left on both sides, right? Isn't it? Now 295 you just observe. Okay. Suppose if that Q is a constant, right? If Q is a constant, when that Q is a constant, and what is the relation between these two? V is inversely proportional to this K, na? That is the relation you are having. Similarly, if which one this K is a constant, suppose if that K is a constant, then you can say that V is directly proportional to which one? This Q. Now, similarly, if V is a constant, whenever that V is a constant, what is it you can say? Q is directly proportional to that K, right? Like that. Is it clear? So this is what we have seen, right? Note this and tell me, then we'll move to the next points in the next slide. Done. This is your 295. Now 296. So here we wanted to get this maximum, na? Yes or no? So practically, if you just consider, right, practically, right, what happens, right, before we define any model, at this k equal to 0, right, what is that k equal to 0? If you just observe, is there any vehicle present on the road or no vehicle is present on the road? When no vehicle or this negligible number of vehicles are present on the road, when you enter onto the road with 0 vehicles, right, what is the speed we can maintain? We can travel with this maximum speed, na? Isn't it? And what is that? Q equal to k into v, 0, you can say. Maximum speed, right? V equal to the v maximum, or this free flow speed, right? Vf is nothing but your which one? This is a free flow speed. But what is that? V SF, you can say, that is your free flow SMS speed, right? By default, which speed we have to consider? That space mean speed only we have to consider, or not? Yes. And similarly, at k equal to that k maximum, what is the k maximum? You can say that is your kj, right? What is the k maximum or this kj? Jam density, right? What is the meaning of this jam density? Density under this jam conditions, na? V equal to 0. Under fully traffic jam condition, do you have any vehicle to move or no vehicle is moving? No vehicle is moving, na? Under fully traffic jam condition, if you just observe, therefore q equal to 0, right? But in both the conditions we are getting that q equal to 0 only, but it is better we have to get this q equal to 0 or q equal to maximum is important for us. For k0 it is q0, for k maximum also q0. So for in between this 0 and this k maximum, kj, you will be having this q maximum, right? Isn't it? Like, so now fundamental flow models, you can say, right? What are these fundamental flow models? The first and foremost one is what? Green shield model, right? So whenever it is that a green shield model, it is also called with which name, you can say? Linear model. Okay, what is the meaning of this linear model? If you just observe, the relation between them will be a straight line or it is something else? The relation between them is a straight line, na? So what is it given? That v equal to Vf into that 1 minus k by this kj, right? This is one relation, you can say. Then k equal to what is it? You can say kj into so this is what we are having, right? So into kj into 1 minus v by this vf, right? 1 minus k by kj or kj into 1 minus v by vf, right? This question was asked in the recent examination. Now what is the q you are getting? K into vf into which one? Q equal to k into v into that 1 minus k by kj, right? K into vf into, isn't it? Add came without skip button. Okay, very good, very good. Now, so here what is the q maximum you are getting? If you just observe, q maximum equal to that kc into that vc, right? What is the kc into that vc? Kc is nothing but your capacity at which location? Sorry, density at which location? Capacity conditions, that is kj by 2 into what is the vc, velocity at this capacity condition, that is your vc by 2. So therefore the Q equal to the Q maximum. What is the K you are having? K equal to Kj by 2 and V equal to Vf by 2, right? Like that you are having. So this is your which one? This is the maximum flow and corresponding which one? Maximum flow and the corresponding density and this is speeds. Okay, note this and tell me. Note and tell me. Yes, at K equal to K maximum. What is that we have mentioned? K equal to K maximum means under fully traffic jam condition. Under fully traffic jam condition, I am explaining that only. Under fully traffic jam condition, do you have any member to move? Under fully traffic jam conditions, right? Any members will move or any members will not. Any vehicle will move forward or any vehicle will not move forward. Tell me. No movement and no movement means, right? What is the flow you can say? What is it? When full vehicles, no vehicle is moving. No vehicle is moving means no flow automatically. No flow means zero flow. Is that clear? That is your which one? This 297, 298 na? And when you are considering this 280, 298 or 288, yeah, 298. Now if you just observe it, relations. Green shield models, right? What is it you can say? Fundamental diagrams, right? What is the fundamental diagram between which parameters if we just observe? Which parameters, between which parameters we have to take this fundamental diagrams? That is your V versus this K. What is the diagram? Anyone having idea? Next, this is your Q versus this K. V versus this K you can say, right? So what is the V versus this K you are getting? So that is your straight line relation between this V and K, or which relation you are having? The straight line relation only, no? This is your which one? This Kj jam density, maximum highest possible. This is Vf, free flow speed. Okay. Q versus this K, right? How it will be? It will be like this. That is your Q maximum. And what is this you can say? That is your Q maximum. Corresponding to this Q maximum, right? What is it you can say? That is your K equal to that Kc is equal to that Kj by 2 na? K corresponding to the capacity, right? Kc into the Vc. K corresponding to the capacity. So this is your V versus Q na? V versus Q. Okay? Got it? At V equal to the Vf by 2, Q equal to Q maximum. At K equal to Kc or this Kj by 2, what is it you can say? That is Q maximum, right? So here we'll be closing the session with this green shield model gets over, right? Any doubts? Anyone having anywhere in our discussions till now? Any doubts anywhere? Any doubts anywhere, Pawan? Okay, if no doubts, I'll close the session. Thank you all of you. Have a good day.